So why Angular 2? Angular 2 was conceived as a complete rewrite to Angular 1 in order to fulfill the expectations of modern developers who demand blazing speed and responsiveness from their web applications. By offering faster initial loads, improved change detection, and improved rendering, Angular 2 is up to 5 times faster than its original build. Angular 2 is sleeker, and it composes a more simplified API. Many of the original constructs have been removed in favor of easier to remember patterns for writing our code. Angular 2 is modern. By copying the huge success of the React framework, it decided to put web components at the heart of Angular 2. As a result, Angular applications are now much more responsive to changes in state. The latest version of JavaScript, known as ECMAScript 2015 or just ES 2015, wasn't around back when Angular 1 was first created. By taking advantage of some of the new features such as classes, modules, and decorators, Angular 2 takes building these sophisticated, high-performing applications to a whole new level. Angular 2 is written in Typescript, which is a superset of JavaScript. And I absolutely love writing my code in Typescript. And the reason is that Typescript gives us all of the enhancements of ES 2015, including future ES7 enhancements, as well as built-in strong typing. So what hasn't changed between Angular version 1 and version 2? I'm happy to say that the core concepts are still around. And that is to help developers create modular, maintainable, and testable applications. Angular 2 provides a variety of options when choosing a language to code in. We can use ES5, which is the current version of JavaScript, Dart, CoffeeScript, either of the newer versions of JavaScript which are known as ES 2015, as well as a future version of JavaScript known as ES7, or Typescript, which really is the preferred language. And no matter what language you're choosing, everything gets transpiled or turned into browser-readable ES5 JavaScript. To see some of the examples of different language options and how they're used in Angular 2, let's navigate over to the Angular.io website. By clicking the Get Started, we are presented with the reference docs. And on every page, we see a clickable option for displaying one of 3 different code selections, so we could choose Typescript, ES5 JavaScript, or Dart. Angular 2 is itself written in Typescript, and most of the examples, courses, and tutorials you'll see on the web are also written in Typescript. Google selected the use of Typescript when writing Angular 2 because of the awesome language enhancements Typescript provides. So let's now take a moment to introduce the Typescript language and understand the benefits of using Typescript. Now that we've made the decision to code using the Typescript language, let's take a brief look at some of the core language characteristics as it relates to Angular 2. Typescript is a superset of JavaScript, and this means that we can write valid JavaScript in a Typescript file and it will get compiled and work just the same as JavaScript. This diagram represents the all-encompassing features that Typescript includes. So you can write TypeScript code using all of the features of ECMAScript 5, which is the current version of JavaScript. You can also use all of the new features of ES 2015, which includes arrow functions, module loading, classes, inheritance, let and const variable definitions. And you can also write TypeScript code using special features suggested to be included in a future version of JavaScript called ES7, which includes type annotations, type checking, interfaces, generics, and decorators. We'll be covering each one of these using examples as we get to them while building our Angular application. Really, the most heralded feature of TypeScript is that of type annotations, which creates what's called strong typing. Strong typing involves giving everything a data type. So every variable, function, and function parameter has a declared data type. We define our data type by using a colon and then the type that we want to declare. And these types are the same basic data types you're already familiar with, such as strings, booleans, arrays, and numbers. Here are a few examples of strong typing. In the first example, we declare a class property of page title that has a type of string and is being set equal to the string welcome. The function and the function parameter examples show you how we're able to define our types by placing this colon directly after the declared function and function parameter. And then what we're returning must match the declared data type, or we get thrown an error. We can also set our function data type to void when not returning anything. This may seem like a hassle at first, and it certainly did for me, but the benefits actually far outweigh the costs. So there's two main benefits to strong typing. The first is syntax checking, which happens before code execution. So this has a big impact on helping us to find bugs in our code that would otherwise be very difficult to track down. And the second main benefit to strong typing is it helps to create advanced development tools and editors like Visual Studio and Sublime Text. Some examples include code completion suggestions, syntax highlighting, and command line error checking. And to quickly sum up the main benefits of TypeScript, number 1, enhanced JavaScript language features. Number 2, better support for syntax checking using strong typing. Number 3, additional editor tooling such as auto-completions and code highlighting. TypeScript was created by the people at Microsoft. There is a very useful website called typescriptlang.org, and here you can find a sample section that provides plenty of code examples, as well as a playground section where you can play around writing code in JavaScript and seeing how it compiles into TypeScript. Hello and welcome back to Angular 2 Essential Training. In this video, we're going to look at our developer environment. So you want to make sure that you have Node.js installed, and I'm currently running Node.js version 4.2.3, but any version that is version 4.0 or greater will be fine for your system. And if I open up my Node.js terminal window, you can see that I'm running 4.2.3 on 64-bit. So you want to make sure to choose whichever Node.js download is right for your system here, and then follow the instructions. If you're on Windows, you'll need to edit your environment variables to include a reference to the Node.js executable. So once that's downloaded, you'll want to pick an editor. So you probably already have an editor that you're familiar with. A few of the popular ones here are Visual Studio, which is great for TypeScript because it's developed and maintained by Microsoft, both of these, so they have really excellent tooling. Brackets works fine. It has a nice plugin for TypeScript. So Sublime Text is what I'll be using for this course, and it's actually my preferred text editor, and it has a lot of really easy to use plugins, in particular for TypeScript. So I'm going to open up my packages by going to Control-Shift-P. If you don't already have TypeScript installed, then you're going to click on Install Package. And then once this pops up, you're going to put in the keyword TypeScript. So it's not really coming up for me the one that we want. The one that you want is this TypeScript Sublime plugin. And that's what it's going to be called. It's going to be called TypeScript Sublime plugin, and it will include everything that you're going to want for the annotations, for the auto suggestions, for the compiler. So it comes with a lot of nice features. And I can show you what it looks like again in mine. I'm going to go Control-Shift-P, and I'll just go to List Packages here. And it's going to be towards the bottom. It'll be this TypeScript right here. So once you have your development set up, you're going to want to install TypeScript as well as typings globally. So you'll want to open up your command prompt, and I'm in my Node.js command prompt, And all I need to do is say npm install and then Typescript, and then make sure I add the -g flag. So this is going to globally install Typescript on my Windows machine. Now this is already installed for me. So for now, I'm just going to kill this operation. You'll want to make sure that you go through and make sure that Typescript is installed on your computer though. And I'm also going to install typings. So you want to say npm install typings then -g as well. So now that we've installed Typescript and typings globally, let's switch back to our Sublime text. So here I've opened up a Typescript file, and what I wanted to draw your attention to is two things. Number one, if I comment out this import statement, we'll get a squiggly line right away for our decorator component. So this is what I mean by really nice error checking. The same thing with if we're importing something that's not there. So for example, if I take away this @ sign, I'll get a squiggly line. And another cool thing is auto completion and recommendations. So within this Angular core, there's 4 methods that are defined in this file. You have components, directives, pipes, and injectables. So I'm able to add in these other methods by saying comma and then, for example, pipe. Then as soon as I type the P, boom, I get the suggestion of pipe. So if I enter that in, I'm able to add it and no squiggly line appears. But if I try to add anything else that isn't within this file, say interface for example, then I'll get a squiggly line. So that's all that you really need to get your development environment set up is a text editor that you're familiar with, have Node.js installed, and then Typescript and typings installed globally. In the next video, we'll be looking at our starter files and setting up our first Angular 2 application. Welcome back to Angular 2 Essential Training. In this video, we're going to look at the different ways that we can set up an Angular 2 application. So setting up an Angular 2 app isn't trivial because we need to make sure that we have the right dependencies both for Angular and for Typescript. So we have 3 different options when creating our setup. The first option is going to be to use Angular CLI. So here I am on cli.angular.io. And at the time of this recording, the Angular CLI has entered into an alpha phase. So you can use it, you can test it out, but it isn't in full production use. In the future, this will be the #1 way that we create our Angular apps, because once we use this generator, then we can easily create components and routers and services right through the command line. So it makes starting our apps a lot easier. So that's the first way. The second way is to follow the Get Started guide on angular.io. So if you go to angular.io, then click Get Started here, it's going to give you a 5-minute quick start setup for how to create your Angular setup by hand. So it takes a little bit of time, but you can see there's 5 different steps. And first is to download and install Node. And then it's going to have you create a folder and create some files, package.json, tsconfig, typing, system.js, create a root component, and so on. So what I've done is just supplied you with a boilerplate. There's a number of different boilerplates that you can find online for Angular 2. And here's mine right here. So this is going to be within your resources folder. So you can either download this, and it's going to be what's in the starter folder right here. So you can either download what's in your resources and open up, and it's going to look exactly like this right here. Or you can download it from my GitHub. So the GitHub URL for the starter files that I'm supplying you with are jackblack/learn-angular2. And this starter pack is very similar to what's in this 5-minute quick start that we just looked at. and it follows this Angular style guide. So throughout this course, I'm going to be showing you how to build your Angular apps according to the best practices of Angular as defined in this angular.io/style guide. So I'd recommend you have a look at this any chance that you get to see the various conventions that Angular suggests when creating your application. So there's lots of different conventions with regards to naming, code structure, as you can see, directives, services, all this. So we'll make sure that we follow this guide so that you're creating elegant code that's readable for yourself and for other developers. So once you've downloaded the starter files, you want to navigate to the location within your terminal. So I'm going to say cd and then go to the location of my folder, and all you need to do is say npm install, and this is going to download all of your npm modules as well as the typings folder and files. If you scroll up, you should see all the packages that have been installed and downloaded. And if you see some error messages down here, you can just ignore these. In this video, I'm going to explain our app structure and how these files work. And it's okay if you don't fully understand everything right now, but as we go through the course, things will become more clear. So let's start off with our index.html file. At the top here, we define our site-wide CSS files, and then down below, we link to our JavaScript files. These 4 files right here are polyfills needed for older browsers, as well as a zone.js file, which is used within Angular for change detection. Below that, we have a reference for our systemjs.config file. This is a file that we use to load up all of our Angular modules. We use the system.import method and then pass in a parameter that does the work of loading up all the defined modules before our app is started. Now, to better understand what's happening, let's open up our system config file. So first, our map object defines where to look for important folders, such as the app folder, which defines all of our front-end files. Then our packages object defines which file is going to be used to bootstrap our application along with a default extension. Below that, we define our Angular packages we want to use in our application. All of these packages can be found inside of our Angular folder within our node modules. Our main entry point for our app is the main.ts file. So let's open up this main.ts file, which is located in our app folder. So in our main.ts file, we're initializing Angular using the class called Bootstrap. We will be covering this in depth in our Bootstrapping Angular video. Our main.ts file is located in our app folder, and again, the app folder contains all of our front-end code, including an assets folder which holds our images, along with a home folder and a shared folder. So let's now open up our package.json file. We use our package.json file to define which packages we want to download from NPM, as well as to start our server. Under the dependencies, you can see a list of our Angular dependencies we require in, along with our ES6 polyfills and Bootstrap, which we use to style our app. Below that, we're declaring some dev dependencies. Here we have our Typescript package along with typings, which is needed for Typescript compilation, along with a light server that creates a server so we can easily run our code inside of our browser. Back at the top, we have a scripts area, and here is where we compile our TypeScript code into JavaScript, start our server, and then watch for changes made to any of our files. Next, let's open up this tsconfig.json file. So this file provides the settings for our TypeScript compiler. All the code that we write in TypeScript files gets turned into browser-readable ES5 code. So this file defines how our JavaScript files should be created. And finally, we have a typings.json file, which holds ambient type definition files used by Typescript in order to understand libraries that we're using. In this case, we're only using one extra library called ES6shim. Again, this will become more clear when we get to the section of this course on TypeScript interfaces. In this video, we'll run our application for the first time. So now I'm going to navigate to the location of my folder and make sure that you've already typed npm install. And once you've done that, all you need to do to start your application is type NPM Start. So there were a couple of messages that quickly appeared at the top. And what it did was it compiled our TypeScript code into JavaScript code. It created JavaScript files. It launched our server, and it's waiting for any changes. So if we look back into our files, we can see that there is now a main.js.map as well as a main.js file. And these files contain the transpiled ES5 JavaScript that the browser is reading. So you can see that the browser was launched, and I'm going to bring this over a little bit and open up my index.html file. And what I can do here is I can make a simple change, say ... save the file, and it gets automatically reloaded and saved within our browser. So now anytime that we make any changes to any of our files and save them, we'll have new JavaScript files created, and a browser will be run to display our changes instantly. So now that you have a basic idea of our starter files and what they do, let's now discuss this concept of bootstrapping and how it loads our Angular application. So far, we've seen our application structure and run our app, but we haven't yet loaded up Angular. All we've done is display this body text found in our index file. So to start using Angular, we need to load up our root component through a process called bootstrapping. Our systemjs.config file sets our main entry point and contains a line that looks like this, setting our main entry point to our main.ts file. Then the main.ts file imports a bootstrap function from Angular core, which in turn loads the root component of our app. Best practice tells us that we should always name the root component of our app component, and also by convention the file is named first by the feature and then by the type. We'll be covering components in depth, but for now understand that components are at the heart of Angular and always include a class as well as a decorator. Let's now bootstrap our Angular application and create our first component in the process. So let's open up our main.ts file, and in this file we're trying to bootstrap an app component class that doesn't exist, and that's why we're getting this squiggly line. So let's create this file now, and I'll right click on my app folder and I'll name it app.component.ts, following the file naming convention of feature then type then extension. So opening up this file, the first thing I'll do is define my class and name it app component. I want to export this file to make sure that other files can use our component. So now that we've defined the class, let's switch back over to our main.ts file and notice that the squiggly line has gone away, even without having to save our app component file. We'll declare a property within our class and name it page title, followed by a colon, and then the data type of string. Then we can define a default value, which we'll call dev book store. Next, let's go ahead and define the component decorator above the class. We always begin with an @, then the name of the decorator. The component decorator is a function, so we need to type parentheses. And then we're going to pass in an object, so we add the curly braces. These decorators add metadata to the class, so you can think of this as extra functionality containing key value pairs for our class that we've defined. Notice that we are getting an underlined error here, and the reason is because we need to import component from Angular core. So we'll say import, and then we want component, and we're getting this from Angular core. Now the error goes away, and we can complete the metadata. So within our component metadata, we first need to add a selector to provide a name for the directive when used within our HTML. The current convention is to prefix the selector with something to identify as part of our application. So we'll use BS for bookstore, and the second part of the name represents the component name, so we use app. Next, we'll define the template. And with defining the template, we can either reference another file or put in any valid HTML code. We can use either single or double quotes, or we can also use backticks. And the backticks are located at the top left of your keyboard, and they are needed if you're spreading out your code into more than one line. So within our template code, let's use Angular data binding here to display our page title that we defined in our class, along with the string to display below. And that's it. You've now created your first Angular component. But how do we use it? So all we need to do is add the selector that we created called BSApp into our index.html file. Once we've done that, we can go back into our terminal and restart our application. And now we have successfully bootstrapped Angular and are displaying our first component. Pretty sweet. Notice here how the content didn't immediately appear. So we can go into our index file and we can also add some text inside of our element in order to display a message while the content is loading. Let's take a step back here to understand the concept of modules. Modules act to create containers around our files. So anytime we create a new file, we're also creating an enclosed module for that file. Modules assist in organizing our code and help to create namespaces for every file. We're then able to export and import these modules into other files. And in doing so, we're able to use the defined classes, constants, and interfaces defined in those outside modules. We've already seen an example using module loaders. When we created our app component, we exported a class and then imported that module and specified the class that we wanted to use inside of that module. Notice we're using the import keyword followed by the name of the class that we want to use inside of curly brackets, followed by the keyword from, and then the name of the file. We can omit the extension since this is defined already in our system config file. Components are at the heart of Angular 2. In this section, we'll discuss the nuts and bolts of creating these components. This will include what's involved in constructing our component decorators and classes, how we can create nested components that also work as directives, and how we can define styles and templates inside of our components. Components are the foundation of modular development. They allow us to separate our code into easy-to-manage chunks based on features and uses. Components descend from other components in a tree-like manner. This app component represents the root component in our tree structure, so that all future components will become a descendant. For example, we could have a navigation component, a sidebar component, and a post component. Then inside any one of these, we can nest other feature-related components. In this example, we could nest sidebar-related component features to create widgets and a calendar. Then if we wanted to, we could easily reuse our widgets and calendar component in other views. And this is what our folder structure would look like for this contrived app, with the widgets and calendar folders located inside of the sidebar folder. The beauty of this modular development style is that each one of these components represent features that we can easily isolate, test, and reuse. This creates dry components in which we're not repeating our code. Additionally, we don't have to worry about any side effects occurring in other parts of our application since our code is contained in its own isolated module. Now that we've explored why building components is a good idea, let's go a little bit deeper to understand exactly what comprises a component and how we should be structuring our components. Components are always comprised of a template, a class, and some metadata. The template is the view layout. It is created with HTML and includes all of the binding, directives, as well as additional syntax that's expressed within the view. Our class is the code that supports the view. It is created using Typescript and includes properties and methods. Properties are used to define data elements, and methods are function expressions used to define some logic. Metadata is the extra data used for our class inside of a decorator. This metadata tells Angular how to instantiate the component, construct a view, and how to interact with other components using directives. In Angular, a class becomes a component when it is given this metadata. Here is our app component that we created as the root component to our application. Recall that the first thing we did was declare our class and export it for use in other modules. We use Pascal casing as our naming convention. This means that we capitalize both words app, which is our feature, as well as component, which is our type. When defining our class composition, we always put properties at the top and use camel casing syntax. So this means that we have the first word lowercase and the second word, if there is one, as uppercase. Methods are placed below properties and also follow the convention of camel casing. We then declared our decorator. Decorators are built-in features of Typescript and are always prefixed with an ampersand symbol. Angular uses this feature to create custom decorators in order to add additional metadata about the class. When creating our decorators, we're actually just creating functions. And you can tell this is a function because it contains parentheses. Then inside the function, we declare an object. This object has a number of optional properties depending upon our decorator. A few that we've already used are selector, which defines the component directive's name, as well as template, which defines the component's view. We then made sure to import our component features from Angular core, so we're able to create our decorator below. In this video, we'll discuss how to use components as directives and how to use external templates and styles within our components. So let's go into our app and open up the home folder. In here, I've already created an HTML file as well as a TypeScript file. We'll use these files in order to create a new component and then add that component as a directive inside of the app component to display when the site is loaded. So opening up our TypeScript file, I'll first create a class and name it Welcome Component. And I'll also just add a single property named page title and set it to the string of welcome. Next, I'll create my component decorator and add a new selector of bs-welcome. We always want to create a selector when we intend to use our component as a directive in another file. And I'm also going to add a template URL, setting it to the location of our welcome.component HTML file. This HTML file will now be associated to only this component. And the path of the file that we define here is always relative to where our index.html file is located. And then I'll make sure to import our component from Angular core. Let's open up our welcome component HTML file. In this file, we can see here that there is some Bootstrap styling defining a panel area along with an instance of a property binding for page title. With our new component created, let's now add this as a directive inside of our app component. So opening up our app component, there is 3 steps to adding our component directive. First, we need to define a directives key, which holds an array. And then we need to specify our welcome component class. Next, we need to make sure that we import our class so that we're able to use it. And finally, we can use the directive inside of our template HTML by adding the name of the selector that we defined in our welcome component. So we'll save all of our files, and with our application running, we should be able to see a new welcome component that is now being displayed inside of our app component. So let's cover just one more aspect of components here, and that is how to add styling to our specific component. We're able to easily isolate style selectors to individual components one of 2 different ways. Either by defining styles within our decorator like this, so we'll say styles as the key, and then we can add our selectors inside of an array. And by selectors, I mean the CSS styling. So first we need to add quotation marks, and then the syntax here is the same as you would find in a CSS file. I'll create a new class and call it byline, and I'm going to set the text here to green. And then I'm just going to add this class into my HTML file. So we'll save these files, reload our app, and you can see that our text gets changed to green. So you'll probably actually never see styles defined in this manner, either in a real app or even in demo apps. The much more common way of declaring styles is in its own CSS file. So to do that, we'll change the styles to style URLs, and then we can put in our style sheet references inside of an array, since we can list more than one if we'd like, and then define the location of a style sheet that we'll create, and we'll just add the extension to CSS. Then we'll go ahead and add in our style definition, save the files, switch back over to our app, and we can see that it hasn't changed any. We're still displaying the color green for the div that we defined in our CSS file.